Okay, so this is for chapter 1, the chemical world. And in this chapter, we are going to study some of those basics about the chemistry. Chemistry is the science that seeks to understand what matter does by studying what atoms and molecules do. Virtually everything around you is composed of chemicals. All the chemicals are composed of atoms or ions and all molecules. So here is one example. You see the coffee, your hand, or the pencils. In the coffee, there are sugars. So this big molecule is the sucrose. And obviously we have those the small one are the waters and those carbon dioxide. And then the other big molecule is the caffeine. And we know the pencil we use to write is the graphite. Graphite actually is the one format of carbon element. Then the person's hand has like those larger biomolecules such as DNA. Atoms and molecules in the matter. So we know atoms and molecules are the basic building block of all the matters. Atoms are very small. Atoms and molecules are tiny particles that compose all common matters. The atoms are bound together to form several different types of molecules. The bonding forces are called chemical bonds. Chemical bonds are the attractive forces that hold atoms or ions together. The attractive forces are electric attractive forces, such as positive and negative electric charges attract each other, while positive repel each other and negative repels each other. An example of molecule is shown here is a water molecule. In water molecule, we have one molecule consists of 3 atoms, 1 oxygen, the red one, and 2 hydrogen bonded together. And the shape of the water molecule, so this shape of these 3 atoms is a band. Water molecule is a polar molecule. Polar molecule means one part of this molecule carries relatively negative electrical charge, and the other part somewhere between this hydrogen, somewhere here will be the positive charge center. The negative charge center will be somewhere on the oxygen atom. So therefore, we have this type of molecule that has the negative center, positive center are not on the same side. And we see those kind of molecules are polar molecules. The characteristic of water molecule make water a liquid at room temperature. The scientific method, how chemists think. Ways to understand the world. Chemists use the scientific method, a way of learning that emphasizes observation and experimentation. Science consists of knowledge as a result of the senses. 4 case terms in scientific world are the observations. Observations involving measuring or observing some aspect of nature. Then hypotheses are tentative interpretation of a single or few number of observations. Laws summarize the result of a large number of observations. Theories are models that explain and give the underlying causes for many observations and laws. Hypotheses, laws, and theories must be tested and validated by experiment. If hypotheses are not confirmed, they are revised and tested through further experimentation. Some observation can be made with the naked eye. Other observations emerge from experiments that rely on the use of sensitive instrumentation. Observation usually involves the measurement or description of some aspect of the physical world. Quantification involves measurement as part of the observation. It is one of the most important tools in science. Quantification allows you to specify the difference precisely. For example, two samples of water may feel equally hot to your hand, but when you measure their temperature, you may find that one is 40 degrees Celsius, the other one is 44 degrees Celsius. The observation of combustion. Antonio Lavoisier, a French chemist, made an observation about the physical world. Lavoisier measured the property of mass in the process of combustion. The mass of an object is a measure of the quantity of matter within it. Combustion means burning. Observation of combustion experiment is shown in this picture. Lavoisier burned substances in closed container. He measured the mass of each container and its content before after burning the substance inside. He noted that there was no change in the mass during combustion. Now we see the scientific method hypothesis. Observation leads scientists to formulate a hypothesis, a tentative interpretation or explanation of the observations. A good hypothesis is foreseeable, which means that further testing has the potential to prove it wrong. Hypotheses are tested by experiments, highly controlled observation designed to validate or invalidate hypotheses. The result of an experiment may confirm a hypothesis or show it be a mistake in some way. The hypothesis may have to be modified or discarded and replaced by an alternative. The new or revised hypothesis must also be tested through further experimentation. A number of similar observations lead to the development of scientific law, a brief statement that synthesizes past observations and predicts future ones. Lavoisier developed the law of conservation of mass, which states, in a chemical reaction, matter is neither created nor destroyed. Scientific method, scientific theory. One or more well-established hypotheses may form the basis for a scientific theory. Theories provide a broader and deeper explanation for observations and laws. Theories are models of the way nature is. Theories often predict behavior that extends well beyond the observations and laws on which they are founded. So here, the scientific method, observation, law, and theory. Classify each statement as an observation, a law, or a theory. A, when a metal is burned in a closed container, the mass of the container and its contents does not change. So this is observation or law or theory. Looks like this just referring to a simple or single process. So we say this is an observation. Matter is made of atoms. So that explain what's the nature. So can be a hypothesis or can be observation or law or theory. C, matter is conserved in chemical reactions. And that is very general. In chemical reactions, matter is conserved. When wood is burned in a closed container, its mass does not change. So the last one is also an observation. And what we see for these four answers is, so A is observation, D is observation, and then B is a theory, and C is a law, and D is another observation. Which statement most resembles scientific theory? A. When the pressure on a sample of oxygen gas is increased 10%, the volume of the gas decreases by 10%. B. The volume of a gas is inversely proportional to its pressure. C. A gas is composed of small particles in constant motion. Yeah, that's it. D. A gas sample has a mass of 15.8 grams and a volume of 10.5 liters. So what we say is A and B are observations, B is a scientific law, C is the only answer that proposes a model of what a gas is like. So only C is a scientific theory. And this picture summarizes the scientific method or the overview of scientific method. So the starting point is the observation. After observation, we can either form hypotheses or do many similar observations to come up with a scientific law. And scientific law and many other observations can make us to make more hypotheses. And then both hypothesis and law and even theory has to be continuously validated or invalidated by experiment. So the experiment can either confirm your hypothesis or confirm the law or confirm the theory. Or the experiment tell us we have to revise our hypothesis or revise the law or revise the theory. Scientific method experiment. Scientific theory are tested and validated by experiment. If a law, hypothesis, or theory is inconsistent with the findings of an experiment, it must be revised and a new experiment must be conducted to test the revisions. Over time, poor theories and law are eliminated and good theories and law, those consistent with experiments, remain. Example, the scientific method, the atomic theory of John Dalton. So this is a picture of Dalton. Dalton explained the law of observations of mass by proposing that all matter was composed of small, indestructible particles called atoms. Dalton's theory was a model of the physical world. It went beyond the laws and observations of the time to explain these laws and observations. Example, a student measured the volume of a gas sample at several different temperatures. The results are tabulated as follows. Formulate a tentative law from this measurement. So here's the temperature, here's the volume. You can do many different type of mathematical calculations, see if you can get some kind of equation or pattern. You can multiply the temperature with the volume, or you can divide the temperature and by the volume and so on. So what we say is that if you take the temperature, each temperature here has a volume, and if you do the division or the ratio, for example, the first pair is 298 Kelvin, and the volume is 4.55 liter. So if you take 298 divided by 4.55, you get approximately 65.5. Then you continue to do that, you will get the same meter number. The second pair will be 315 divided by 4.81. Approximately, you also get 65.5. Example, interpreting graphs. Examine the graph in this figure 1.5 and answer each question. A. What was the concentration of carbon dioxide in 1960? So this graph, the horizontal x is the year. The vertical x is the carbon dioxide concentration part per million. It's kind of a unit, very similar as a percentage. So this is the graph. And the first question is, what was the concentration of carbon dioxide in 1960? What we do, we first locate this 1960 in the horizontal axis here. So 1940 is here, 1980 is here. So we can just draw a line. This line here, 1960, and go up, intersect with the graph, and then go to left to the vertical axis. Then we see the number of the point is somewhere between 320 and 300. In the middle, so this will be 310. So therefore, we estimate, if I mark it here, so this is 310. And the line you want to read is that point. So therefore, we read approximately this is 318. If you estimate, if you're reading that 317 or 319, so in this range, all are acceptable. But the book reading is 318. Okay, so then you will do the similar to read the concentration of CO2 at 2000. First, locate where is the year 2000. So here's 1980, here's 2020, and in the middle will be 2000. You go up, intersect here, and go to the left, so that will be 370. All right, now once you get that number, you know the concentration in 1960, the concentration of CO2 in 2000, and then you see how much increases, which means you want to find the difference. So therefore, you are subtracting the carbon dioxide concentration in 2000 by the carbon dioxide concentration in 1960 and find the difference. So here is our formula. We plug the 370 for the concentration of 2000 and we plug in 318 for the concentration of 1960, and we subtract, we have 52 ppm. And then D is what is the average rate of increase over this time? So you're talking about the rate. Well, the average rate of increase over time is the change in the concentration divided by the number of years that passes. And determine the number of years that has been passed by subtracting the initial year from the final year. So our initial year is 1960, and our final year is 2000. So therefore, we take 2000 subtracted by 1960, we get 40 years. So now the rate is change in concentration divided by number of years. We see from part C, the change in concentration is 72 ppm. Number of years from part D here, we know the 40 years. So therefore, we take 72 ppm divided by 40 years, we get 1.8. The unit will be ppm per year. E. If the average rate of increase remain constant, estimate the carbon dioxide concentration in 2030. So determine the increase in concentration between 2000 and 2030 by multiply the year or number of years that pass in that time interval by the average rate of change from part D. So from part D, we know it will be 1.3 ppm per year. Between 2000 and 2030 will be 30 years. So that for 30 years, the total year multiplied by the rate, we will get this much of change for the concentration of CO2. But the question is, you will estimate the total concentration of carbon dioxide in 2030. So therefore, we were adding this much change, adding this much on to the value we have in 2000. We see in 2000, we're reading from graph is 370. Therefore, 370 plus what we newly gained. So this how much will add on or gained from like 2000 to 230. So therefore, we will have the total. So this will be the total. Chemistry requires curiosity and imagination. You must want to know the why of things. You must do your work regularly and carefully. If you do, you will be success. You will be rewarded by seeing a whole new world, the world of molecules and atoms. Questions, answers to all the questions numbered in blue appears in the answers section at the back of the book. The exercises in the problems section are paired. And the answers to the odd number exercise numbered in blue appears in the answer sections at the back of the book. And then those even number is similar. So do the homework and do some of those examples we have in this lecture, and you will get ready for the quiz. And once you are ready for the quiz, then on the exam, most of the questions, at least 60 or 70% of the question on the homework is the same as the question on the quiz. So the quiz you will have